video, I will be going over how I made this Star Wars themed box in order to house some home automation electronics. Just as a disclaimer, I'm not a professional, I have very limited tools available, but if you are in the similar position to me, then you might find this video interesting. This is a die-cast aluminium box I'm starting off with. I went dumpster diving for this. As you can see, it's got lots of holes and cutouts already made in it. I've had to go around these as I don't need these holes for my project. Ideally, I would like to use a CNC machine or a milling machine to cut these out, but as I don't have either of those, I'm just using a bit of masking tape and a Dremel with a cutting tool on the side. I've got the lid clamped to a table on top of a sacrificial piece of wood. That's so I can still clamp this tightly to the table, but it doesn't matter when I go through the lid. The nature of using a rotary tool, such as a Dremel, on these boxes is that because it's circular, you can't get right to the edge. So the way I got around this was to use an open-ended hacksaw and just continue the rest of the cut into the corners, kept it nice and neat. After I'd cut into all the corners and the centre plate still remained, I just used a hammer and bashed around all the corners. It is a little bit cowboy, but it's quick, fast and kind of fun. These are called Hammond boxes. They are quite expensive. You can buy them new online if you don't want to cut out big areas where they've been used before, but I like to use these as it's a good cost-saving exercise. Nothing fancy here, I just used a Sharpie pen and a set square in order to draw the lines out neat. The only thing that you have to look out for is that the sides of these die-cast boxes are tapered, so you can only really get a perpendicular measurement from the top and the bottom of the box. Once I'd cut out all the holes, I just used a rat tail file to smooth off the edges and square off the corners. These tend to be very forgiving and you can tidy up all your sins that you've made from cutting it with a rotary tool. Again, they're not as clean and perfect as you would get on a CNC machine, but I don't have that at my disposal. My main tactic so far has been to cut out the large areas where connectors and switches had been put before for the box in its previous life. I've decided to use some car filler in order to clean up these holes and just mixed it on the side there, and then the idea is that you then sand that flat once it's cured. The large areas I had cut out was because there had been holes there from the box in its previous life. They do double up this time though as windows to let light out, so you can get a good effect at the end. The Perspex windows, all I did to cut those out was to measure them with a ruler, score them deeply with a Stanley knife and then snap them over the edge of the workbench. This way you get a nice straight line. The only drawback is that on these boxes, because I've used a Dremel tool and a rat tail file to get the straight edges, there are imperfections and the windows don't quite marry up. I haven't thought of a good way of dealing with that so far. Here I'm using a power sander with a coarse grit paper on the back. I then switched to a finer grain in order to get more of a finer finish. I do quite like the pitted matte effect of the paint, so I won't go too crazy with the sanding. All I'm doing is countersinking all the holes where I will need to screw standoffs from the other side. I'm just using a countersink tool on a hand drill. The fixtures I do have are not countersunk themselves, but this just makes them slot in a little better. It's not completely flush, but that won't matter because the box is standing on its bottom, not on its back. Here I'm using methylated spirits in order to clean up the surface, preparing it for the primer. Now I've used Sharpie pens to mark this box up, and on water-based spray paints the Sharpie will dissolve and penetrate through the paint. So no matter how many coats you put on there, you'll always see the Sharpie marks. So I learned that the hard way, so definitely go over and make sure there's absolutely no marks from any Sharpie pens. You can also see that the piece of towel I'm using is absolutely filthy. Aluminium's a funny one, it's never really ever clean. You can wipe it down and wipe it down and wipe it down and it'll still look dirty because of the way the surface oxidizes. So you just have to be happy that you've got as much of the grease and solvent pens off as you can. I'm wearing gloves here not because the chemicals I'm using are hazardous, but just because they're alcohol based, they dry your skin out. That's all. Once I've cleaned the surface, I then prime it with a white primer in just a spray can. Here I've got this hand tool which makes it the movements a little easier. Obviously the thing with spray cans to avoid is dripping, so I'm just doing this very gingerly for the first few coats. The paint I'm using here is actually red brake caliper paint. It's oil based, so it's really sticky. It's actually horrible because it gets everywhere and is really hard to clean off, but it does leave a really nice shiny finish at the end. So if you don't mind putting yourself in full spray paint protection gear, I would definitely go for that for a nice finish. So here we have the box so far. It's been primed and then had a coat of red paint on the outside. Now I've got the stencil of the Stormtrooper. This was printed out on thick paper rather than card, just so that it would go through the printer, but thick enough that the paper won't curl once it's got spray paint on it and is wet, so you can't use ordinary paper very well. I'm using a fresh X-Acto blade on here. It cuts through really well through the thick paper and is much more versatile than if I was to use a Stanley knife, for example. Once I've finally cut out all the stencils, I just lay it out just to make sure I've got all the parts ready for spray painting. You can see the little white marks where I've gone outside the line. The spray painting stencil technique is really forgiving, so it doesn't matter that I've not been 100% accurate. I'm just laying the stencil out on the box now, so I'm doing a few things here. I'm making sure that I've got no colour divide over a single screw, so that the screws will be either black or white. I've also lined it up to the original drawing I found online, so that I've got all the different parts of the stencils lined up correctly. So to spray paint the stencil, I've just laid it down and put some bolts on the top to weigh down the stencil. It's thick paper, nearly card material, so that it's not curled when it's wet from the spray paint. I've left the paint to dry for a little while. It's still tacky to the touch, but I've just taken the weights off the top and peeling off the stencil to see the result below. As you can see, it's a really forgiving technique. If you're rough of the edges or if the paint gets underneath the paper, it just adds a really cool effect. I then finished the box with a clear lacquer. The red brake caliper paint on the front I left because that's got a really nice finish, but on the back I was sure to go over with a clear lacquer. I did this outside, and even in the most shaded areas there's still enough wind that the coat was not even. It was thick and thin in parts, and then had the cobblestone cracking effect in the thicker areas, so I will make sure that I always spray indoors from now on. You can see where I've blended in the black and red paint. I did this on purpose. It's added quite a cool effect. This is a really tricky part of the build. I've got the Perspex windows and I'm just using cyanoacrylate super glue. Go around the edge of the Perspex windows and put them in place. It's really difficult because if that cyanoacrylate touches the Perspex, it discolours it and it looks awful. I can't think at the moment of doing this any other way. It's not ideal. I'm going to have to think of a better way to get around this. So here I'm now testing out the electronics. I've just laid those out on the table. It's an Arduino Mega with an Ethernet shield as the main driver of the circuit. There's DC to DC power converters, power resistors to break down some of the voltage, and then I've got all the inputs for monitoring the mains and monitoring temperatures in the water heating system. I'm just using my web interface via Raspberry Pi to turn the relays and the LED on. I love using relays because you can hear the click and you get that audible feedback that your circuit's working. Now I know the circuit is working correctly, I can now load this into the box. I had done this originally, so I know this fits. I just have to be a little careful now because there are painted surfaces and I don't really want to scratch the paintwork I've done. Now I've got most of the electronics in there, it's pretty cozy. The length of wires is always a difficult one to get. You want it long enough so there's enough play that you can adjust things inside the box, but you want them short enough that you don't have too much wire hanging out all over the place. So here we have the completed box with everything still functioning inside. The actual function of the box is to monitor the power, the mains that I use in the flat. It also turns the hallway lights on and off, as well as some other lights. It also monitors the temperature of the hallway and the temperature of the hot and cold water. Well, that's the end of the video. I hope you found it interesting. Thanks very much for watching.